Hello and welcome back to the second video in our lab tutorial. If you haven't already watched part 1, I would encourage you to go back and watch that one before you continue with this video. We'll be using the software tools that we downloaded and installed in that video. Okay, so before we start, I just want to briefly go over the process for how these experiments go. We start off with the physical thing that we're measuring, that might be dropping a ball or rolling a car across a track, and then we have to measure that data. So we sometimes measure it with pencil and paper, or with the smartphone sensors, or with a spring balance, or something like that. Once the data is already collected, then you just upload it to the computer, either by copying it into a spreadsheet, or uploading it to a cloud and then downloading it onto your computer. The first app that we'll be looking at here is the measuring tool, and that will be for measuring angles. So on my iPhone, I'm just going to go ahead and open the default measuring app, which I will use then for the level. If you have an iPhone, just go ahead and use this one. It's super easy to use. If you have a different phone, then go ahead and find your default app on there or download one on your app store. Okay, so the easiest way to look at it, why don't you just check the level of the table you're using right now. As you can see, I've got 0 degrees right here, which shows that the table is level. I can flip it up to here, and again, it shows 0 degrees. This is what we want. We want numbers for the angle. We don't want to just see a line or a bubble that moves around. We actually need a number that we can record for the experiments. So for this one, you can see I can tilt it up. I get 25 degrees. I can get 30 degrees. That's what we want. So just play around with that. Make sure you know how to use the level app on your phone because we'll be using that for several experiments. Next up is the Firefox app, and again, this is a sensor app for your phone. It uses the sensors that are built into your phone, like the accelerometer and the microphone. The tools in this app that you might want to use are the accelerometer without G, that's without the acceleration of gravity, acceleration with G, the acoustic stopwatch, the audio spectrum, and the inclination tool. The inclination tool could be an alternative for the measure app, but I found that it wasn't quite as easy to use as the default measure app or other measuring apps. At this point, I'm going to switch over and do this on my phone, and you can follow along on yours as well. Okay, let me briefly explain the difference between acceleration without G and acceleration with G. The main difference is acceleration without G. They just subtracted the acceleration due to gravity from the acceleration reading that you get from that. Otherwise, it's the exact same thing. So for the experiments that we'll be doing, it doesn't really matter which one you want to use. Both of them will work just fine. For this, I'm just going to go ahead and grab acceleration with G. I want you to press play on there, and that will start recording data. And you can look through, we've got acceleration in X, acceleration in Y, and acceleration in Z. Now, the first question you should be asking is which directions are which for those phones, because they're going to be related to some axis through your phone. So we've got an axis this direction, an axis this direction, and an axis coming out like that. What I want you to do is just pick a direction and move your phone really fast in that way. So go like this. And then you can go like this, and then move it this way. And now if you look through these 3 graphs, you can see that we've got spikes on each one of those for the time that we did it. And looks like I did it a little too close together, so I can't tell which one is which. So I'm going to do that again. All right, so let's move it this direction. So, all right, let's see. So that one looks like that's Y. So the Y-axis for my phone is going through like that. And then let's move it this way. Okay, so that was X. You can see the accelerometer in X. That one was what moved for this. And now let's move it the other direction. And as we would expect, that one was Z. So now you've identified which directions are which for the accelerometer axes, and that will be something would be useful to know for some of the later experiments when we're using this tool. So go ahead and record that in your eJournal for this experiment. Just draw a simple diagram of your phone, and then you can label the 3 axes, X, Y, and Z. Also for this part, take a screenshot of your phone for this. So you can either do it landscape like this, or you can flip it portrait. But just take a screenshot and include that for this part of the experiment. Okay, so I'm going to go ahead and stop that. And the next part that we want to look at is how to export this data. So When you get done with your experiment, you can either export all of the data or you can export part of it. So I've either got access to the acceleration in X, acceleration in Y, or acceleration in Z, or if I swipe over, it's the absolute acceleration. So this would be just all of the acceleration combined into one. So if I want to export all of the data, I can just go up here and click these three dots. Clicking those, that gives me the option to export the data. So I'm just going to go ahead and click that. And here you see it gives me several options. I've got Excel, and then CSV with comma, and then with tab, semicolon, and so on. The one that we're going to want to use for most of these experiments is CSV, the CSV with comma. CSV just stands for comma separated values. It's just a Excel format that allows you to import data as a text document rather than an Excel document. So that's how we're going to be doing most of these. So if you just go ahead and click Export Data. Now I got options here. So the one I'm going to do is Drive. That'll be Google Drive. And when it goes to there, then you can pick one of your accounts. So I'm just going to pick my Andrews account and then click Upload. If you want to rename it, that might be a good idea. I'm not going to do that for right now because this is not really an experiment. But when you're doing this for the labs and you're doing multiple runs with several different values, it's good to name your values that way. The next tool that we're going to look at is the acoustic stopwatch. So just go ahead and scroll down to that. It's listed under timers. And go ahead and click on acoustic stopwatch. So the way this tool works is it's just like a normal stopwatch. It starts and stops, but the thing that controls that is sound. So it has these two numbers. It has a threshold and a delay. The threshold is how loud do you have to make a noise in order to start and stop the stopwatch. And then the delay is the minimum time that it will look for between claps. Like if you clap your hands, the delay is the time that it will wait between one clap and the next for stopping the stopwatch. Okay, so I'm just going to go ahead and use the default values. You can play around with these and see if a different value works better. I wouldn't set the value too low. The lower the threshold just means that the stopwatch is more sensitive to noise, so it takes a smaller amount of noise to set it off. Okay, so let's just go ahead and play with that. Hit start on there, and you can see I've already got a noise. I don't know what that was. I must have just bumped the microphone when I set this down. So go ahead and hit reset. A lot of this actually might be my voice. So for this part, I'm just going to stop talking and just clap. So basically, if you click reset and then clap once, and that will start the timer, and then clap again, and that will stop the timer. So go ahead and watch that now, and you can try it yourself. Alright, so you see it's going, and I spoke, and now it stopped. So let's just try that again, and I won't speak this time. I said I wasn't going to, and I did. Okay, so reset. Okay, and you saw that? It just started and stopped with each clap. So obviously the threshold is low enough that my voice keeps setting it off, so that's something you might want to consider when you're doing this experiment. There are some other options here. You can either flip to sequence, and it gives you multiple times. For most of the time, we don't want to use that. Just use the simple one because we just want a single time. Then you're going to write stuff down and then go back and do it again. So in between times, just go ahead and hit reset and then do it again. So just go ahead and play around with those. You can adjust the threshold and the delays and see what effect that has. I would recommend keeping it on the default, although that might be different for different phones, so you might need to adjust that depending on what phone you have. The next tool that we're going to look at is the audio spectrum. So just go ahead and click on that. It's under acoustics and then audio spectrum. So this frequency graph, it's got frequency on the x-axis and magnitude on the y. So the way this works is the x-axis is all of the frequencies that it can pick up. So all the way from 0 up to usually 0 to 20,000 hertz is the most likely range because that is the range for human hearing. Your microphone probably can't pick up all of those, but those are probably the frequencies that you're going to be seeing on here. So then the magnitude is just how strong or how loud is that given frequency. So you'll see how it works once we get started here. I'm just going to go ahead and hit play. And you can see here we've got all of the different frequencies bouncing all over the place. I've got no strong single frequency right now, so it's just basically a lot of noise. You can zoom in and out on the graph. So let's see here, if I pinch and zoom, I think I can make that work. Actually, I think I have to click the graph first. Okay, so if I click the graph, then I've got these other tools. So I've got pan and zoom. You can pick data, and that will be important later. So now if I'm on pan and zoom, now I can zoom out on the graph, I can scroll over, and you can see more of the frequencies. So that might be useful if you want to zero in on certain frequencies and pick the data more precisely. So what I want you to try here is just go ahead and whistle. If you whistle, you can see a given frequency. If you can't whistle, then just go ahead and sing a note or something. So let's try this. You saw that spike there. Okay, so now I'm going to try another one. So you can see we've got frequencies jumping all over the place, and that's what we want to see. So I'm going to go ahead and do this again, and while the spike is up there, I'm going to go ahead and hit pause. Okay, so you have to hit pause while it's still going, otherwise it just goes away. Now you can try this. We can click pick data, and I'm going to, actually first of all let's go pan and zoom, and I'm going to zoom in on that just a little bit, and then pick data, and I can click on that peak, and it'll tell me what the frequency is. So it looks like that one is 1701 hertz in some decimal places. So this will be useful for labs that involve sound when we're looking at frequencies, and you can just go ahead and record your sound, click pause while it's still going, and then use the pick data tool to select your frequency and record that value. For this part, let's just go ahead and take a screenshot, and you can take a screenshot of this graph and then record that in your eJournal. The last tool that we could look at here is the inclination tool, and I'll just show you that briefly, but we're not going to be using it much unless you really want to. So it's got a lot of different ways to look at angle. It's got tilt up and down, tilt left and right. I haven't found that it's very easy to use, but you can certainly play around with it and see if that would work better for you than the angle tool that I showed you earlier. So if I just click record right now, it just kind of jumps all over the place. So I can click on this graph maybe and look at it a little closer. If we tilt it, you see the value changes. So yes, it could work. You can stop it. You can go to pick data. You can click on some value. I kind of like the constant one where you can just set it up simple and then read the value. But you're welcome to try this if you want to. If you don't have access to another measuring tool, then this might be a good option for you. And that's it. So there's other tools on here on the Firefox app that we're not going to be using for this lab. We might be using them for second semester if you stick around for that. But for now, these are just the ones that we're going to look at. You might play around with some of the other ones just for fun, but these ones are the three that we're going to be using for this lab. For this next part, I'm going to show you how to use the spring balance from your lab kit. If you already have your lab kit, then please follow along and try this yourself. And if it hasn't arrived, then just watch the video, and once your lab kit comes, then please try these things so that you're ready for the labs. Alright, the first thing we need to do is attach the spring balance so that it can hang from something, and we can hang things from it. The way we're going to do that is with some duct tape. And if you just tear off a strip of duct tape, then you can just loop it through the top ring on the spring balance. And just wrap it around to the back side, and then tape it to itself, like that. And then all you have to do is just tape it on the edge of a table, or whatever thing you're using for your lab. Now that the spring balance is mounted, we need to zero it. And zeroing it just means we have to slide this metal scale part up or down until it matches up with the red mark from the hook. So you can either do this three ways. You can align the zero with the top edge of the red thing, the bottom edge, or in the middle. I like to do it on the top because it's easy to see, but you can do it differently if you want to. That looks good, and you just want to make sure that it looks like it's zeroed when the spring balance is just hanging, nothing on it, and definitely when it's hanging from the hook. If you have it from here, then it might be a little different. See, if I lift this up a little bit, then the mark moves around a little bit. So to be the most accurate, you want to have it hanging from the hook, and then zero it at that point. For some labs, you won't be hanging the spring balance like this, but you might have it flat or angled or something like that. And if that's the case, you'll need to zero it in that orientation, otherwise the calibration might be off. The main idea is to position the balance how you'll be using it, and then zero it at that point. Now I'm going to show you how to weigh a few things using your spring balance. So we'll just start with a Hot Wheels car, and to do this one, if you're able to, just hang it from the axle of the car or something on the frame. If you could do that, you can just hang it right like that, and then check the weight. It looks like this one is about 40 grams. So you can try that with yours if you have your lab kit already. The other thing I'm going to show you how to weigh is the rubber ball. You have 2 of these in your lab kit, so if you have your lab kit, you'll want to try this. These ones are a little difficult because, as you see, there's nothing to hook it on. I can't just stab the hook into it. That would be bad. So what we're going to do is just use a small piece of duct tape. And I'll just tear off a strip of that. And then you can just hook it to the top of the ball so that it makes a little loop. Alright, so you want something like that. And then you can just hang it on there. And once it's hanging and stops swinging, then you can just check the mass, and that's how you weigh things. For some experiments, we will be taping duct tape to the rubber balls. I would encourage you not to leave the tape on there any longer than it takes to do the experiment. If you do, the tape might leave residue on the ball, and that might mess up some of the other experiments, so just take the tape off when you're done, and you'll be good to go. For the last part of this video, I'm just going to do a simple experiment, and for this part, just go ahead and watch, and then in part 3, we'll do the analysis together. So the experiment is super simple. First of all, I'm just going to place the ruler in frame of the video so I can see both ends, and that will allow us to calibrate our footage later when we do it in Tracker. And then the other thing we're going to do is just roll a ball across the view in front of the camera, and just want to roll it close to the ruler. Don't want it bumping into the ruler, but just roll it straight across, and then we'll track the motion later. And now the camera's rolling, and I'll just go ahead and roll the ball. We'll do it a couple times just to make sure that we get a good run, and that will be it. And now I've stopped the video, and that will be it. After this, I'm going to go ahead and find one clip out of that that looks good, find one of the runs that we just did, and then I'll export that. I'm going to do it through Google Drive. You could do it any way you like if you want to use email or Dropbox or any other way that you want to do it. And then when we get to part 3, I'll download that clip and we'll analyze it in Tracker.